This conference will now be recorded.
Good afternoon, everyone. My name is Maurice McHugh. I'm with the GOZAR Program Office, and I'll be your host today. The title of today's presentation, today's Satellite Book Club presentation, is Science to Service Methods During a Violent Tornado in Southeast Iowa during the historic March 31st to April 1st, 2023 tornado outbreak. Our presenter is Zach Utek, lead meteorologist from NWS WFO Quad Cities, and our facilitator is Jorel Torres, Research Associate 2 and JPSS Satellite Liaison from Sierra. Before we get going, just some quick reminders. First of all, please remember that the session is being recorded. Please be sure to mute your microphone and turn off your webcam. We'll have a Q&A session after the presentation. Please, I would like to encourage you all to post questions in the chat room, and we will field them through there. Also, please sign in with your full names or specify your full names when asking a question in the chat. And we're always looking for future presenters for Satellite Book Club presentations. Please get in touch with the Tower S team, Kishad Bowman and Emily Maddox in particular. I want to thank Jorel Torres and Zach Utek for their help in today's presentation. Zach Utek is a lead meteorologist at the Quad Cities WFO and has been in the National Weather Service for 12 years. Before arriving at the Quad Cities, he began his weather service career at the Great Falls, Montana WFO, and he has a BS in atmospheric science from the University of Wisconsin-Madison and an MS from the University of Wisconsin-Milwaukee. His passions are forecasting winter weather and working severe weather operations. Zach, welcome to the Satellite Book Club, and take it away.
All right, thank you for that nice introduction, and I'm excited to be here today presenting. Originally developed this presentation for AMS back in January, but today I'll be adding more of a satellite flavor to it, and excited to get going here. So my motivation to put this presentation together was kind of all-encompassing. It was to demonstrate the importance of consistent forecasts and messaging on both a national and local level in developing invaluable decision support services for National Weather Service partners and the public for what was a historic tornado outbreak. So this tornado outbreak I'm talking about here today occurred on March 31st to April 1st, 2023. And on the national scale here, it accounted for the third most tornadoes on record for an event, with 147 surveyed across 16 states, 44 of which were significant tornadoes at being EF2 or greater in strength. Unfortunately, there were 29 severe weather-related fatalities and over 200 people injured. And over the course of the 2 days, the National Weather Service issued a total of 175 tornado warnings. Next slide. So focusing in on eastern Iowa, northwest Illinois, so this map here on the right is centered on my home office county warning area, the Quad Cities. Our tornado outbreak occurred on March 31st, 2023, and we set a record for one event with 29 tornadoes, and over half of those were rated EF2 or greater in strength. We had 15 of those at EF2 or greater, and then what was pretty impressive is looking at the national perspective here, that accounted for 34% of the EF2s, and that's just across portions of eastern Iowa, northwest Illinois. We did have 11 injuries, but 0 fatalities, which is pretty amazing considering the severity of the event. But I think that is a testament to not only the exceptional warning services that we provided that day, but also the critical DSS that my office provided leading up to and throughout the event. Next slide. So this graph, the red line shows the violent tornado climatology. So looking at EF4s and EF5s across the United States, it uses a 3-week rolling average between the years of 1950 to 2022. And what you see, what really stands out is that rapid increase in frequency of violent tornadoes during the mid to late March period. So that places this event we're talking about here today right on schedule. The lighter shaded line then is restricting that data to areas that are north of 40 degrees north latitude. So I thought that that may show maybe a bit of a delay in the increased frequency for violent tornadoes, but again, it's right on schedule there with an increase in the late March period. And we did have, so in our area there in eastern Iowa, northwest Illinois, we did have one EF4 tornado. So that made it the 12th violent tornado to occur north of 40 degrees north latitude prior to April 1st. So pretty amazing stat there. Next slide. So the Storm Prediction Center did an excellent job here forecasting this event well in advance. This is way out at the day 5 outlook. And you can see they already had a 30% probability for severe weather. So essentially an enhanced risk extending from the Wisconsin-Illinois border all the way down south into Arkansas. And then if we step ahead, one more interesting stat here is that this was only the second time since SBC began their day 4 through 8 convective outlook back in 2015 that the Quad Cities county warning area was in a 30% on day 5. So definitely a testament to the potential severity of this event. So then if we jump ahead to the next forecast outlook, so this is the day 2 outlook, and you could see that there's definitely a ramp up there now taking on a bimodal character with a moderate risk over eastern Iowa, northwest Illinois, and then another moderate risk area down towards northeastern Arkansas. And already at this time, SBC is messaging the potential for significant and long track tornadoes. So then we'll jump ahead to the day 1 outlook. So this was the final outlook for the event, and now an upgrade to a high risk in those 2 areas with a moderate in between. So they're still mentioning the threat, the potential for strong and long track tornadoes, but even mentioning violent tornadoes at this point. And if we step forward one more, so this was the first SBC high risk for the Quad Cities county warning area in nearly 10 years. Go forward. So I did a little bit of research, tried to create some composite analyses on days that there were significant tornadoes in the Quad Cities county warning area during the spring. So we're looking at March, April, May through the years of 2008 to 2022. So the upper left image there is a 500 millibar height composite on those days with significant tornadoes. And as you expect, you see a trough over the central and northern plains, and it looks like it is taking on a bit of a negative tilt. Upper right image is the 850 millibar wind composite, and you see a strong low-level jet of at least 35 knots. That's infecting Gulf of Mexico air northward, so warm and unstable air mass northward into the mid to upper Mississippi Valley. And you step forward one more. So we can compare those composite analyses to analysis for the day on March 31st during the afternoon. The lower left image is a 500 millibar height analysis at 22Z on March 31st. So you see that deep trough in the central to northern plains with a negative tilt, but with deeper magnitude. So I think that is just signifying that this is potentially a very anomalous event. And looking at the 850 millibar wind analysis, lower right image, similar to the composite, but stronger values, 50 plus knots infecting warm and unstable air mass northward. And you can see that the terminus of that jet is near the eastern Iowa, northwest Illinois and southern Wisconsin area in the vicinity of what was a northward moving warm front. Next slide. So with the satellite data here, we'll just start in the upper levels. Of course, the first thing you really see is the deep upper low there rotating over portions of South Dakota, Nebraska. And then you can kind of visualize a strong upper jet rounding the base of that trough with the exit region over the mid to upper Mississippi Valley. Just step forward one. And that is our area of interest here through the presentation today, but you can see the convection, strong convection developing central to eastern Iowa and pushing off to the east. So really in a favorable area for upper divergence to not only initiate convection, but maintain it as it spreads to the east and northeast. So we'll step forward and just drop down lower in the atmosphere, the lower level water vapor. So this can be used to help track location of an elevated mix layer. Of course, not all areas that you see that are brown and red are necessarily the elevated mix layer, but if you kind of track it back, so if you start over eastern Iowa near the Mississippi River and track it back, you can see that the source region of that air mass is likely over the southern Rockies to southern plains as it moves through Kansas, Missouri, and then it pushes more to the north. And just hit forward one. So my office is located there, that is Quad Cities, and we are an upper air site. So we can kind of see here, we did a special sounding in addition to the 12Z and the 0Z on this day. So we can just see how quickly this atmosphere changed and became very unstable. So go to the next slide. So 12Z sounding, March 31st, not very impressive. So mid-level lapse rates only about 6 degrees C per kilometer at that time, dew points upper 40s. But if we go forward here, one, just jumping ahead 6 hours. So this was our special sounding at 18Z, and look at the change, especially note the change at 700 millibars. You see significant drying and even warming too. So that steepens the lapse rates to about 8.5 degrees C per kilometer. Very impressive. You can see the development of the elevated cape there too, and that sounding. Next slide. So again, this is a special sounding, the 18Z, but looking at some more of the details here, the surface-based cape, of course, there was some surface-based sin at this time too, but the surface-based cape was really impressive for this time of year, being as far north as we are, with already 1,500 to 2,000 joules per kilogram. One thing that was really impressive were the dew points that eventually reached near 60 or lower 60s. And looking at the climatology, that only is observed on 1% of March days in the Quad Cities. So if we look at the corresponding photograph, it shows very strong kinematics here with effective bulk shear 70 knots, 40 knots of shear just in the lowest kilometer. And that yielded storm relative helicity values near 260 meters squared per second squared, again, just in that lowest kilometer. And you can see the location of the right moving supercell. So that would suggest that storms that are moving off to the east-northeast would maximize the ingest of storm relative vorticity in this situation. And we'll definitely see that as further on here with the Keota, Iowa supercell that is moving off to the east-northeast and is definitely very discrete in nature. Next slide. The National Weather Service Central Region Remote Mesoanalysis chat room was active this day on March 31st. This is an example of some of the information they were providing to us. So here they were using NSSL's warm forecast system, and the map there is showing the 0 to 2 kilometer vertical vorticity. You can think of that as a proxy for low-level mesocyclone strength and longevity. It did happen to catch on to our dominant supercell that produced an EF3 and EF4 tornado. It's that feature that develops more towards south central Iowa and then tracks off to the northeast, kind of in the direction of Iowa City. Next slide. So we'll take a look here at some of the mesosectors. So definitely these are very beneficial while working severe weather operations, of course, with the increased temporal resolution. This is one of the favorites, the GOES sandwich RGB. So you get the structure of the visible satellite imagery, but then you also get the details with cloud top temperatures. We did have some pretty strong convection ahead of the main tornadic line. That's the convection that you see over northeast Illinois. Those cloud top temps were very cold, but I believe that convection was at least partially elevated, where the more surface-based, deeply rooted convection was back to the west, and you can see it approach the Mississippi River towards the end of the animation. So that's kind of the area that we're more concerned about. But what you see, and even in that area, even though the cloud top temperatures aren't quite as cold, you still see overshooting tops. You do see persistent enhanced V signatures. And then one thing that happened towards the end of the animation is you had a transition from semi-discrete supercellular structure to more of a linear QLCS structure. But even at that time and past the time of this animation, the storms continue to be tornadic. So we still have development of very strong new updrafts there towards the Mississippi River, even as it's transitioning to more of a linear feature. Next slide. So I like to look at the GLM flash extent density. Here I overlaid that on top of the visible satellite imagery, but it really helps, I think, with identifying strengthening updrafts and then potentially which storms are most likely to be severe. I think it definitely gives you some lead time on that in terms of giving you a heads up and potentially issuing a warning or maybe increasing the severity of a warning. The lines that I have plotted, so we had an EF3 tornado near Martinsburg, Iowa. That's the orange line. The red line is the EF4 Keota, Iowa tornado. And you can see how close they are there. The times for those were from 2049 Z to 2137 Z. Not a lot going on with the flash extent density for the EF3 tornado, but if you watch it closely, you do see an increase in the flash extent density as it approaches the red line area. So that would be the EF4 tornado. See a bit of a jump with that, definitely, I think, showing that there was some increase in strength there. Although if you look at the whole field of view here, not necessarily stronger than surrounding storms, but it's definitely stronger than relative to what it was doing 20-30 minutes prior to that. Next slide. The simple water vapor RGB is not something that I look at too frequently, but there are a few things I noticed that I wanted to point out. And just a reminder is that the simple water vapor RGB helps distinguish where moisture return is occurring in clear areas and highlights corridors of low to mid-level moisture. So you see the area of deep convection approaching the Quad Cities, but if you look further back to the west, there is an area of like darker purple, and I think that is enhanced moisture that's just ahead of the cold front. So you see, and then you'll quickly see a new area of convective initiation that's further west. It's a kind of a thin line, but it really stands out in this simple water vapor RGB, and I think that would just give you a heads up that you may have another round of convection coming in from the west. I think that is either just ahead or right along the actual cold front, and eventually that merges with the convection that's downstream. That may be when we had that change in morphology from semi-discrete to more of a linear mode. Next slide. So here is our dominant supercell. We're calling the Keota, Iowa supercell. And this is a radar animation that covers a period of about 2 hours, 2020Z to 2022-17Z. We have half-degree reflectivity on the left, half-degree correlation coefficient on the right. Over its life cycle, it produced a total of 5 tornadoes. Again, one was the EF4. And looking at the correlation coefficient, you do see a persistent tornadic debris signature that develops early on in the animation. But what's really interesting is that debris is lofted further up into the storm. It's advected downstream, so you'll see the lower CC values spread out to the northeast into the forward flank of the storm. Can't say that I've seen that very often. This supercell was able to stay discrete for quite a long time. It was really off to the east of the other convection and had this unimpeded southeasterly flow, kind of an untapped air mass flowing in to the updraft region. And then eventually the convection catches up from the southwest and the supercell is absorbed. But like I was saying, this line of storms then continued to be tornadic even beyond the end of this animation. Next slide. For about a 45-minute period, the average TDS height with this tornado was about 21,000 feet, and it had a peak rotational velocity, not for the whole period, but a peak rotational velocity of 70 knots. You can see the debris being lofted there on that cross section. And if we could try to play this video, just a real short video showing you how ominous this tornado looked, very low cloud heights there, dark appearance, not something that we're too used to in our part of the country, definitely something that you'd more likely see in the southern plains. And then the image on the right, just some of the aftermath there, really significant damage to a home being essentially wiped off its foundation there near Keota, Iowa. Next slide. So my office in the Quad Cities provided critical decision support services to our partners and the public. This graphic is just an example of some of the information that we included in our decision support packets that we would email out to our partners. So we're messaging not only the high risk for severe storms, but also the potential for strong and long track tornadoes. It was one of the first times we conducted live tactical webinars for our emergency managers to help them make decisions through the event. If you click forward one more, we have a close relationship with our area school superintendents. And because of the information that we were providing to them ahead of time, they decided to release school several hours early. So this was on a Friday to give families time to prepare for the high risk of severe weather. And I think that may have been the first time that has ever really happened in our area. Of course, that's more common to do something like that, closing school, releasing for winter weather in our area, but not necessarily for severe convection. Next slide. We received some very positive feedback from our partners. One of the county emergency managers that was near the Keota, Iowa supercell said that on a day when I was overwhelmed by multiple tornadoes hitting multiple counties I was serving, National Weather Service Quad Cities always answered my call. And then we had feedback from the University of Iowa Hospital and Clinics on the live tactical webinars. They said that this was great to have today. Thank you all for setting it up and making yourselves available in real time. Next slide. So to summarize and some lessons learned with this event here, really a historic event, but exceptional forecasts using pattern recognition at both the national level, so SBC, and the local level, the local WFO level, led to invaluable decision support services for our partners and even the public. National Weather Service partners depend on the local expertise more than ever, which we at the Quad Cities office provided through frequent updates on radar trends and mesoanalysis of the environment. And then the live tactical webinars help our core partners make critical decisions throughout an event. And what was nice about these is that it's more of like a one-to-many DSS approach. Instead of calling individual EMs. This reduces the workload for National Weather Service staff. And then lastly, they're ending with the satellite data, so definitely useful in many areas. Of course, the pattern recognition of a setup that was supportive for a significant severe weather outbreak, placement and strength of a deep upper low and a jet X region, and then also advection of the elevated mix layer leading to rapidly leading to a very unstable air mass. And certain things that I haven't looked at a lot, but like the simple water vapor RGB helped identify areas of enhanced moisture and location of boundaries. And then some of the more common features using the infrared to monitor the most prominent storms through overshooting tops and persistent enhanced V signatures. So with that, I think that's all I have here. I can open up for questions and discussion.
All right, thanks, Zach, for that great presentation. And what I'll do is I'll encourage attendees to please stay on for additional discussions here. And also, we encourage everyone to, within the GoToMeeting interface, to change their viewing settings to active cameras from the default view. And just a few additional items to mention before we get into the discussion. First thing here that is shown on the screen is that in a week from today, on Thursday, June 20th, at 12 p.m. Eastern, Christopher Smith, the GOES-R satellite liaison to OPC and WPC, will discuss satellite imagery usage and cases at the Ocean Prediction Center. So we can look forward to that next week. And then also, I'll encourage attendees to also contact the TowerS team, Kashad Bowman and Emily Maddox, for questions about the SBC or for configuration of satellite products. And then also, as we transition to the discussion, I'll also remind attendees to submit their questions via the chat and or indicate if you want to ask the questions verbally within the chat room. So Zach, we'll get started here with some questions. And the first one I have for you is actually from Bill Schoberg. And within your analyses, did you check the NewCap soundings or the satellite-derived soundings that are available from the polar orbiters? Zach, I can't hear you. Can anyone else hear him?
Try again.
Okay, I can hear you now.
No, unfortunately, we did not check the NewCap soundings that day. But yeah, with it being a high risk, and there wasn't a lot of question, obviously, with initiation. You know, it was more of just monitoring the environment, and we knew the shear was very high and the environment was very conducive for tornadoes. But yeah, we did not look at the NewCaps.
Okay, and as a follow-up to that, there's I think at that time, because this was last year, and at that time you would have been able to access one set of NewCap soundings from the NOAA 20 satellites, but now, this is more just an FYI, but users now have access to not only NOAA 20, but also NewCap soundings from NOAA 21 and METOP-C. So you'll have additional data sets just for the future. You can be able to access in your AWIP system. But in addition, from NWS RNK, they said, do you have any suggestions, best practices on how your office was able to survey 29 tornadoes? Thank you for the excellent presentation.
Yeah, I think especially today is mutual aid is becoming very important. So I believe that we had La Crosse at that time back us up and really take over our grids and the forecast, so we could just focus on sending people out into the field, and then also all of the post-event wrap up and working in the DAT and communicating with the media and partners. We could focus on that in the office. So I would definitely utilize your office mutual aid and try to do it that way, because yeah, it was a huge undertaking. It took us many days and many teams out in the field.
And did you personally survey that EF4 as well? Or
no, I was actually back on the day shift, so I was in the office working at that, doing the post-event wrap-up.
Okay. Another question popped in here from NWS Sioux Falls. Can you talk more about the content and timing of the live webinars and any best practices you took from that? Was this more of an open Q&A or like an hourly briefing, etc.?
Yeah, so that was one of the first times that we did those. So we kept it pretty open. I think we've tried to make them a little bit more concise now. So we would try to conduct them. We're actually transitioning to doing them in Slack now and conducting them maybe every 30 minutes to an hour. But in between that time, we're doing mesoanalysis. So it's not necessarily like you're saying, okay, there's a new warning issued here. We're really kind of trying to give like a 1 to 2 hour forecast of where we expect there's potentially severe weather, where to be concerned. And the foundation for that is the mesoanalysis. So that the person that is in that role, they're doing mesoanalysis, but then what they're really doing is DSS and helping message to partners.
Very nice. And also, Bill Schoberg adds a comment. I believe he's referring to Christopher Smith is also giving a Leo seminar on this upcoming Monday, the 17th of June, if you can make it as well. In addition, I see Bill Line added a question here for you, Zach. He says, do you or forecasters in your office prefer the default AWEB sandwich RGB or manually creating your own visible IR sandwich with overlays?
From what I've seen, I think most of my coworkers use the sandwich RGB. I did see one of your presentations recently where you had some alterations to the infrared color curve. So I think those could prove to be very beneficial. So yeah, we would definitely be interested in at least testing those out.
And as a follow-on to that question, a question for myself. So like for that particular day or that type of weather setup, with respect to satellite products from GOES, what do you typically go to? What are your go-to? I saw within your presentation a variety of, whether it be the visible, the sandwich, RGB, the water vapor channels. What are, from your experience, what do you go to in observing the severe weather?
So I would say that the cloud phase distinction RGB is very useful, helping with determining areas of convective initiation. But on a day like that, there wasn't a lot of certainty. There wasn't really waiting around for convective initiation. Once they started to develop, they went extremely fast. So really, for me, one of the most useful products is simply just looking at the infrared and monitoring the overshooting tops, the cloud top temperatures, and monitoring that change, looking for enhanced view signatures, because then you're kind of able to compare storms to one another. The strongest storms definitely stand out. So I think that is probably the most useful product. And then, of course, if it's a mesosector, you get the 1 minute temporal resolution, which is very nice.
Yes, indeed. And in addition to just like satellite products, I didn't see it through the presentation, but I was just curious if you're aware of the products. Are you aware of the advected layer precipitable water, or ALPW product, that provides your precipitable water values in 4 layers that could also be used to observe the moisture component with respect to severe weather?
Yes. I don't think we had access to those to get those into this presentation, but yeah, those are very useful too.
Mm-hmm. And you use that product often as well?
Definitely look at it, and then of course there's other derived products, like looking at the CAPE, the GOES CAPE, which can be less than what you would expect, but I think it's looking at the relative sense of that value, just looking at where the bullseyes, where the gradients, and that kind of helps you determine where the convection may be forming.
And as I wait for more questions in the chat, I had an additional question here. I was really intrigued by your graphic on, I think it was slide 6, referring to the 40 degrees latitude. And just with respect to the violent tornadoes and everything, within your CWA, is your entire CWA north of 40 degrees latitude?
I think it is very close to that line. Yes,
Okay.
that
Okay.
latitude. Yeah.
Yeah, I just thought that was a very intriguing graphic there of what you were showing there in the percentages of
And
violent
then
tornadoes.
just 1 year prior, there was an EF4 tornado in Winterset, Iowa. I can't remember the exact date, but I think it was pretty early in the year. So that's just to the southwest of Des Moines. So we had 2 EF4s in 2 consecutive early spring periods there. So yeah, it's been very active up in our part of the country.
Okay. And then also during your time there, because remind me, how long have you been at WFO Quad Cities?
About 10 years now.
Have you observed an EF5 at all?
No.
No, just EF4s.
No.
Okay.
Yep.
Let's see here. I'm still waiting to see if there's anything additional in the chat. So wait another minute or two here. And I'm just looking through my notes here to see if I missed any questions. Oh, I did have one last question here, if I don't see anything in the chat. But with respect to severe weather operations for your WFO, I assume that most of the GOES data that you view in near real time is through AWIPS. Do you by chance observe any of those data sets online as well, or is it mainly just in the AWIPS interface?
Yeah, I mostly rely on AWIPS. I think one thing we do in my office is we have radar assistance.
Okay.
Especially for the higher end events like enhanced, moderates, and highs. So these radar assistants, they're set up at PCs, so they may not have access to AWIPS. Well, in that case, then yeah, you're going to be using satellite data from the web. I think typically it's the College DuPage website that we're looking at for that, but that would be a situation where you're not relying on AWIPS. But if you're the warning forecaster, I've got all my radar panels on my main page. It may be anywhere from 6 to 16, depending what I'm looking at. And then on my other monitor, closely monitoring the satellite trends and the lightning data too.
Okay. And I figure if you're deployed for any kind of event, are you using AWIPS in the cloud?
We are not yet. So
Okay.
that would be heavily reliant on the web then, yeah.
Okay. Good to know. Good to know. But with that, I don't have any additional questions, and I don't see any additional questions in the chat. So what I'll do is I'll wrap up here. Thanks again, Zach.
Thank you.
And I'll turn it back to Morris for final remarks.
Thanks, Jorel. I appreciate it. And thanks to Zach for a great presentation. Unfortunately, my camera is not working today. It worked an hour ago on a different call, but I can't get it to work with this software. So thanks to everyone for participating today. Thanks for the great presentations. The Q&A was fascinating. The imagery, unbelievable in the presentation. So thank you, Zach, for putting all that together. So in the chat, there's a link or two that Emily pasted in. If you want to share any feedback on this session, there's a link right there at the very bottom of the chat. And at the very top of the chat, Emily also pasted a link if you want to help out as a facilitator or presenter. So thank you all for the presentation today. Thanks to Kashad and Emily and Lee and others at the TowerS team. And we hope to see you all back again next Thursday or a Thursday very soon in the future. Thank you all.